Laser. Light amplification, stimulated emission of radiation. Characteristics of laser: high directionality, higher intensity, monochromaticity, and highly coherent beam. Wavelengths and colors. Monochromatic light is seen with a certain color depending on its wavelength. In this experiment, to determine the wavelength of the given laser light using diffraction grating, apparatus required: laser source, grating, screen, and meter scale. Formula: wavelength of laser source, lambda equal to small d divided by capital N M capital D. Unit: meter, where small d distance of the nth ring from the central spot of the diffraction pattern in meter, capital N number of lines ruled in the grating per meter, M order of diffraction, capital D distance between the grating and the screen in meter. Number of lines per meter calculation. Here grating value is 2500 lines per inch. 1 inch equal to 2.54 centimeter. Now we convert per meter. 2500 divided by 2.54 centimeter equal to 984.2519 lines per 1 centimeter. Multiply 100, so capital N equal 9.8425 into 10 to the power of 4 meter. That is the value of capital N. Now capital D is distance between the screen and grating, otherwise small d1 is a left side spot beam diffraction, d2 is a right side spot beam diffraction. Here d1 d2 is a distance between the spot beam. Now the grating, fixed in the grating stand. The grating stand is placed in between the laser source and screen. Now the distance capital D fixed in between screen and grating, for example 10 centimeter. The diffractions produced: center spot beam to left side diffractions also left side diffraction, center spot beam to right side spot beam diffractions also right side diffractions. Now we measure small d1 and small d2. Small d1, the distance in between the central spot beam to first spot beam diffraction. The distance value noted. Then center spot beam to right side first spot beam diffraction, the distance d2 noted. Similarly, the distance d1 value for second diffraction, d2 value the second diffraction distance noted. Then third diffraction is also noted. Then the grating stand distance value increasing for 20 centimeter, then the diffractions value d1 d2 noted for 3 diffractions. Then distance value increasing for 30 centimeter. Similarly, you calculate the distance d1, d2 noted. So these values are tabulated. Tabulation. The distance between the grating and screen. The distance 10 cm, 20 cm and 30 cm. Each distance we find for 3 order of diffractions. N is equal to 1, M is equal to 2, M is equal to 3. For example, the first reading, M is equal to 1, the distance equal 10 centimeter, D1 value 0.7 centimeter and D2 value 0.8 centimeter. So, small d equal to D1 plus D2 divided by 2, the average equal to 0.75 centimeters. So, these values substitute the wavelength formula. The wavelength formula lambda equal to small d divided by capital N M into capital D. Now, small d 0.75 10 to the minus 2 divided by capital N number of lines per meter 9.8425 10 to the power 4 into this is the first diffraction M equal to 1 and the distance 10 centimeters. The value is 7.620 10 to the power of minus 7 meter. Similarly, we calculate order of diffraction 2, the order of diffraction 3 and distance 20, order of diffractions 1, order of diffraction 2, order of diffraction 3, then 30 centimeters also. Finally, we calculate the mean value for wavelength or lambda equals 7.38 into 10 to the power minus 7 meter.